One particular problem attorneys create for themselves in the age of ChatGPT is when they get ChatGPT to prepare a legal brief for them, and ChatGPT hallucinates. In particular, ChatGPT and really all of the other AIs, they hallucinate the citations to case law that form the bedrock of our common law. Attorneys end up citing cases that don't actually exist, and judges, when they find out, they are not fond of that. You would have thought that the very first attorneys who got dragged in front of judges and groveled, that would have sent a signal. It turns out a lot of attorneys haven't gotten the memo, so it's happening regularly. Now, at the suggestion of my own attorney, I wrote a bit of code that would go into a legal brief, isolate the citations inside of it, and check those for validity. It's not a particularly complicated piece of code except for one little bit. It's the part that identifies the citation. Citations have a very well-defined structure. It's easy to describe what they look like to a human being. To a computer, that's actually more difficult. It involves something known as a regular expression. And that's just about the blackest art that any software engineer is going to encounter. A few folks understand regular expressions. I don't think I've ever met anyone in my 50 years programming who understands regular expressions really well. Most of the rest of us, we just keep plugging away at regular expressions until we get something good enough, and then we leave it alone. But now, in the age of ChatGPT, I can ask the computer to write that nasty bit of code for me. So I did. But it didn't work. It's as if the computer didn't know how to do it. So I asked again with a bit more precision, and again it got it wrong. So instead, I pasted the whole brief with some citations in it into ChatGPT, and I asked ChatGPT, please just pull out the citations here. And then, of all things, it actually wrote a bit of code that it used itself to pull the citations out. It was code far better than any that it had written for me when I had asked. So I grabbed that code, I adjusted it a bit, and I put it into my program, and now it's working. So I've got a tool that will prevent attorneys from submitting briefs with hallucinated citations if they use it. I'll be releasing that tool for free because it wasn't too much work once I managed to sweet-talk ChatGPT into doing the hard bits. I learned something during that about the future of software. There's a whole bunch of people who believe we will be able to vibe our way into perfect programming. But from where I'm standing, it looks a lot more like a slog. G'day, I'm Mark Pesce. The coming next billion seconds will be the most transformative in human history. The arrival of AI looms as one big reason that will prove true. And over the course of these 5 episodes, we're doing a deep dive, delving into the nuts and bolts of artificial intelligence. Is it really that amazing, or is it just so much hype? In our excitement, are we losing sight of the other meaning of AI, that it's always imperfect? That's the title for this miniseries because as good as it is, and yes, it's way better than it was 3 years ago, it still has a long way to go. In this episode, we go to the beating heart of the hype, vibe coding, and we ask if it really is that, or if it's just something tantalizing that can't possibly deliver on its promise. That's on this episode of The Next Billion Seconds. No area has been more transformed by AI than software development. Even before ChatGPT had been released, there was this thing called GitHub Copilot, and I got to play with it. It showed programmers what it would be like to have an AI standing by, ready to assist you with any little bit of code. It was spooky and fun. It felt like the future. But the future is always bigger and weirder and harder than we imagine. So let's fast forward 3 years to right now. We have tools like Claude Code and Cursor, and programmers spend entire days inside of those tools. The CEO of Microsoft, Satya Nadella, he runs around claiming that 1/3 of the code at Microsoft is now written by AI. The CEO of Coinbase says 40% of the code's being written by AI. And I got to tell you, I actually find all of that really hard to believe. And I'm not the only one. There was a bit of research published in July 2025 that spelled it out. Here's their main finding.
Before starting tasks, software developers forecast that allowing AI will reduce completion time by 24%. After completing the study, developers estimate that allowing AI reduced completion time by 20%. Surprisingly, we find that allowing AI actually increases completion time by 19%. AI tooling slowed developers down.
So is this really a revolution in software engineering? Will we never have to code again? Or is it going to be another steaming serve of something that is always imperfect? It's hard to know, which is why I've invited John Allsop to join us on the Next Billion Seconds. A frequent guest in our earlier days, John runs the widely respected conference series Web Directions, and he only last week ran his Engineering AI conference, all about software engineering in the age of AI. John, welcome back to the Next Billion Seconds.
It's great to be here. It's probably been a while, I'm thinking.
I think 2018, so probably been about 7 years.
So quite a bit has happened. In many respects since that last time.
Of course, one of the last times we were on, we had that very engaging conversation about whether your youngest was ever going to have to learn how to drive a car because of self-driving cars. And the answer is, yep, probably she will.
Yeah, so that's one. It's very interesting and maybe salutary and have some value for this conversation. You know, I definitely didn't think that my daughter, who is now nearly 13, would ever need to learn to drive, but I very much suspect that she will in 3 or 4 years' time.
All right. So on the heels of the conference, do your best if you can. Sum it up. What are we really seeing? What is the state of things with AI and software engineering? Is it the brand new eon, or is it just whatever?
So I definitely think that this has already transformed the way we write software, the way we develop software. And at the same time, I don't think we've really begun to properly understand the use cases and develop patterns around them yet. So we're seeing a lot of experimentation, and that was very much a theme of the conference. And at times that can look like failure. You know, we see reports of like overconfidence by developers or, poor ROI on projects. And I think that's actually to be expected because we are very, very early in a time of significant transformation. But I think there's little doubt that transformation is occurring.
Is it changing what people do? Is it changing how they do it? So in other words, I'm sort of trying to break it apart because software engineering has many pieces to it. One of the biggest pieces is actually figuring out what needs to be done. Right. And it's, software engineers do not sit around and just cogitate on their own. Gee, it would be nice if they get a complaint from someone or they get a request from someone or the CEO comes in with the brainwave and then they actually have to do it. And it's always felt to me like that's actually the bigger part of the job rather than sitting around and banging code. So are we talking about one part of the job being transformed, which is the writing of the code, or are we talking about the whole process of what software engineering is being transformed?
Well, I think a lot of the focus at the moment is definitely on that code generation part. And so whether that's people who have never written code before using tools like V0 or Lovable or one of the large language models like ChatGPT or Claude to generate apps, to develop apps, or whether it's, existing software engineers using it, that certainly seems to be the focus. However, that's, as you observe, a small part of software development, of software engineering. And I think we're seeing less of a focus currently on things like testing, on the whole software development lifecycle. And as you observe, on that kind of architecture part, systems architecture part, as well as things like product discovery, as user research, the places where we find the problems that hopefully our software is trying to solve.
And even just the thing that software engineers always complain about, which is all of their meetings. but in fact is often meetings with the stakeholders, the people who will actually be using the tool or people who have requested the changes in the tool to actually work out what they need and how you can best do it and how you can integrate it with all of the other systems that an organization uses these days. It's not like when I was starting out, only one tiny part of the business would have been computerized, would have had access to computers. No one else in the business really had them. Now every aspect of the business is thoroughly digitized. All of these systems are interconnected. And so the software engineer is not operating in a vacuum.
No, and a lot of software is being developed by people who aren't professional software developers or even outside the remit or the knowledge of, the IT kind of department. So, so much of modern business relies on spreadsheets. And spreadsheets are definitely a type of programming. They can get very, very complex. And so all kinds of very complicated, not just financial, but other aspects of a business are being run by things like spreadsheets, things like, Microsoft Access and these kind of more consumer grade databases. So I think we sometimes overlook how software engineering isn't the only way that software gets developed, even in enterprises. And I think the impact there will be very, very significant. I think we will, a lot of the things that are being run in this way will ultimately end up looking like applications. They'll probably be much more productive and much more user-friendly and possibly much more dangerous because they're not in tiny little sandboxes like a spreadsheet or a consumer-grade database anymore. So I think there's some really interesting things happening in that area as well.
I wonder, I have a really good friend who's not a coder at all, really. And she's like, here's this amazing little thing that I did in ChatGPT that solves this particular program for me, right? It's like, and she basically just told ChatGPT what she needed, and ChatGPT wrote all the code and then gave it to her. I think it was all web-based. So ChatGPT has that capability to just give you a web-based program and tap here and you'll be running the code and it's all great. And she's very happy with that. And I can imagine that a CEO or a CMO or a CIO is going to get some wacky idea in their head and tell the ChatGPT to do it and come then to the engineering department saying, kids, I managed to get this in half an hour. What are you all spending your time doing? Are we going to sort of see that kind of, well, look, it looks really easy over here, but in fact, when you're in practice in the field, it's not?
Oh, absolutely. Yes. How hard can it be? I think we already see this quite a bit. The highest paid person in the organization, or the hippo, who often kind of brings the ideas which look, pretty simple. In how hard could it be to X? There's a famous XKCD comic, I think, about, someone saying, we'd like something that allows people to walk in a national park and, plot their, trip or whatever. And that'll take a few weeks. And then we want them to take a photo of a bird and describe what it looks like, what it is, what species, and they say, oh, we're going to need a team of researchers and 10 years to solve that problem. So, there are things that software developers kind of understand are difficult or not. Are they polynomial or non-polynomial problems? And outside our world, it's probably far less obvious. So I suspect, yes, we're going to see quite a bit of that as well.
One of the things that I got from being at Engineering AI last week is that everyone wants to share their tips. It feels a lot like we've got this huge coal face, and everyone's just got a little square of it that they're exploring, and they're kind of mapping out the features on that section of the coal face, and they're making notes. And then when we get together, we all sort of share our notes with one. Did you see this? Oh, no. Did you see? Is that kind of where we are right now?
Oh, absolutely. It reminds me very much of the early days of the web 30 or more years ago, where it was so new that no one really knew anything, and there was a culture then developed of sharing. People would explore and develop a technique and would share it. In the early days of blogging, long before social media, this was a really common part of the web. And I see this also happening now. There's a very, like a culture of exploration and sharing, things that people discover, patterns that people kind of work. I mean, the interesting thing, like the early web, although perhaps even in a more accelerated time frame is that things can very quickly become outdated. Something people learn about a particular model may not translate to even the next version of that model, let alone other models. But there's certainly a culture of that right now, which also presents an opportunity for folks who are software engineers, who are enthusiastic about these technologies, to go explore and then document and communicate that. There's still this opportunity, I think, to be a real pioneer, despite the fact these technologies have been around 3 or 4 years, and we seem to have done so much with them. I feel like we're still very much at the very beginning of.
And you talk about things changing quickly, and I remember one of the speakers made a big point of engineers will build something on top of an AI system, and then there's a new release, and the AI system just doesn't work the same way anymore, and all of the stuff they built on top of it doesn't work. And software engineers are somewhat used to that when they get a new tool that they may have to retool, but I feel as though the frequency here and the degree of the change here is giving people pause around how close they actually want to get to the tool, because they don't feel, not so much that the tools are unreliable, but that the tools are too mutable right now.
Yeah, so I get, there's one argument that, well, they're improving all the time. Why even bother now? Because in 6 months' time, 12 months' time, they will be so much better at what they're doing. So why invest that energy now? I've had that experience myself. So some of the tools I built work with the vision APIs or the vision capabilities, and I have seen them dramatically improve a number of times over the last 18 months or so. But I would argue by being involved or by using them over the period of their evolution and development, you gain a knowledge that I don't think someone who just jumps in at a particular point will have. So I think even when things are in this kind of state of flux and they're very early in their development, by getting to understand them, I think you can start making at least guesses about when they might be good enough to solve particular problems, or maybe even not good enough, to cheap enough, right? I think a lot of this is about the cost of computation dropping, in the order of 10 to 100 times a year in many cases, if you measure it on a per token basis. Like getting a sense of what that means in 6 or 12 months' time. Things today which are very, very expensive, but you can do, will be essentially free in 6 or 12 months' time. And by being on that curve, I think gives you a real opportunity.
And I think the other side of that is that having experience with the tools also allows you to vibe check yourself. In other words, do a gut check about whether something is going to be easy or hard, which is different from expensive or cheap, but just, is that going to be something that's easy to do even with a better tool? And it feels like that's a really important thing to learn, because then you can keep yourself from going down blind alleys that you can't find. But to your point, there's this essay that I shared with you this morning about programming deflation, which talks about the kinds of questions that are approaching software engineers right now. Do you delay until the tool gets better, as you say, or do you start experimenting now? Is the cost of experimenting so cheap now that you might just want to do it now so that you can get it done and then go on to the next thing? Or do you just want to sort of build up a backlog? How do we need to start to think about whether we want to move forward now with the tools that are incomplete and constantly getting better, or wait until we get something that might answer all of our questions and our issues?
So my instincts, so let's step back just a moment. So Simon Willison is one of these people who has been, from the earliest emergence of these technologies, really public and open about his working with them. And he's someone I would highly recommend anybody to follow. Newsletter, RSS.
We'll put a link to his blog on the post.
Yeah, and he observed possibly a couple of years ago that what he felt one of the real values of these technologies is that, look, people like Simon, people like me, like any software engineer, can probably do just about anything given enough incentive and time with a computer system, right? We kind of know basically what's going on. I wouldn't write the best operating system, but if I had to save the world by doing it, I could kind of do it. But it would take me an awfully long time. I wouldn't, be able to begin to estimate that. So what Simon observed was that there's a lot of problems like that not necessarily the scale of an operating system, but like, I could build this thing to do this thing, but, will it take me 2 hours or 2 days or 2 weeks? And so you don't even kind of begin the process because it just seems a bit daunting or maybe a waste of time. Whereas what Simon observed that he'd kind of benefited from, and I've certainly experienced this as well, is you can within an hour or less, get a sense of, okay, is this a 1 hour problem, a 1 day problem, a 1 week problem? You very quickly get a sense of that. And so I think they're really interesting and valuable tools for that sort of experimentation. And to the broader point of, do you wait and see? I would say no. I would say that we're on some sort of exponential growth or, like a rapid increase in the capabilities. And the later you get on the train, I think the more work you will have to do to get up to speed. So those people who have kind of developed these intuitions about how these things work, what they're capable of, how much roughly something's going to cost, these kind of intuitions are really powerful. And the sooner you start acquiring them, I think kind of the longer term value you'll get.
I just want to bring up one of the counter arguments here. There's a lovely piece that was posted to 404 Media, I think yesterday. Software engineers paid to fix vibe-coded messes. And we're actually seeing this pop up in a couple of different areas. We see graphic artists being hired to fix up the images that are being created by ChatGPT and the other systems because they have errors in them. And I think we're now starting to see, the CEO's got this great program and he hands it over to software engineering and they open it up and it's just kind of ugly. And they're bringing people in to clean up these messes. This is a phenomenon that seems to be part of the deal with agentic and generative AI, which is that you really do need quality supervision at every step along the way. And so I guess the question we're asking, and the question that we don't know if we have a definitive answer to yet, is, are we robbing Peter to pay Paul? Are we saving money and time, or are we simply moving it to a different cost?
Yeah, so I think there are two ways people are looking at these technologies right now in terms of business. One is that, I guess, these are cost savings. We're going to be more productive. We're going to need fewer software engineers. We're going to need fewer whatever, right? So it's an opportunity to save cost. I guess in that sense, it's a sustaining innovation. And then there's a different approach, which is to say, what new things can we do here? Maybe because we bend the cost curve so much that it allows us to do things that previously weren't economically feasible. Or, what capabilities, are there that previously were not. So, and then in terms of having a talented group of, say, engineers, rather than saying, well, we can get rid of 30% of them because they're 30% more productive, we could say, well, we can get 30% more out of these software engineers. So I think it comes down partly to what's the instinct various organizations have. And if you feel there's still an opportunity for novelty and growth in our economy, I feel that second approach is the more sensible one. That organizations that simply say, hey, here's how we can kind of cut costs and remove headcount and rely more on machines, I feel, I think in the short term, probably going to benefit. They'll probably look really good to shareholders. Their cash will increase, their EBITDA will look better. But will they, I think this is a real moment of transformation. And that approach, that kind of very conservative approach, I feel closes off the avenues of opportunity. No less because really good software engineers who have capabilities like this are really in demand right now. Like there's a recession in terms of hiring a lot in terms of software engineers and designers, people who are in hot demand for the last 15 years or so. But in this particular area, people can't get enough of them. So if your approach is that conservative, let's get more for less out of our existing team, then the best people will go and find much more interesting and much more, beneficial places to work.
And it goes to the opening observation of this entire series, which is that artificial intelligence acts as a mirror. And really what you're doing is you're getting to see what the organization is about. Is the organization just interested in paring everything down to the minimum and getting the most out of every employee? Or is it about helping the employees be their best for the organization? John, thank you so much for joining us on The Next Billion Seconds.
You're very welcome.
These first 2 episodes of Always Imperfect focused on disappointment, on people trying to wave their magic wand of AI and getting it to solve all of their problems and finding out it's simply not that easy. In our next episode, we'll turn the corner and take another approach, one that meets organizations where they are and then builds tools to meet those needs. Will that work better than all this magical thinking? You'll find out on the next episode of The Next Billion Seconds. The Next Billion Seconds was written and presented by Mark Pesce. Big thanks to John Allsop for joining us. The show was mixed by Luke Cramp, produced by Medium Productive, executive producer Josh Butt. If you like our show, please remember to follow us on your favorite podcasting app, and if you know someone who might be interested in these topics, please share our show with them. This is Mark Pesce, thanking you for listening.